Okay, so in this video we are going to lay to rest the finally one-dimensional collisions and one-dimensional elastic collisions which conserve momentum and conserve kinetic energy. And what I just said is at the end of the last video I said that this awful quadratic here, we do not need the quadratic formula to solve it because we already know one of the factors. Now here's a top-down view of my 1.38 kilogram object coming in at 1.29 meters per second and my 2.57 kilogram object coming in at 3.02 meters per second. Now, and that's going to be a negative on it. Now, that's the possibility that we have in mind. But these formulas are going to work just fine. They are going to give a valid physical result if I have this situation. No collision. Okay, so the mathematics has to work out just fine if there is no collision. So if there's no collision, the final velocity of this after there is no collision should still be 1.29 meters per second. And the final velocity of this, if there is no collision, should also be negative 3.02 meters per second. So if I go back to this quadratic equation, right, here's how I want to lay it out. Just like this, if I plug in negative 3.02 meters per second into this formula, I should get 0. So if I try that, it's a good thing for me to try. If I do 7.34 times negative 3.02 squared plus 22.23 times negative 3.02 plus 0.13, I get negative 0.06, which, because of rounding error, I'm very, very happy with that. That's about as close to 0 as I could expect it to be. There is rounding error all the way through that. So I already know one solution. So here, if I plug, why did I put a positive there? The reason why I put a positive there is because what I'm plugging in for V2F is negative 3.02. So if I plug in negative 3.02 right there, and then I add 3.02, this becomes 0, and then it doesn't matter what's in here. If this is 0, the whole thing is 0. Okay, so now I'm clear to solve. That's probably went by really, really fast, but now I'm clear to solve this because I have one of my roots. Well, now, what goes here, this times this equals that. So what goes here is 7.34 V2F. And then this times this equals that. So what goes here is 0.13 divided by 3.02. Okay. So then, finally, what I end up with is I have 7.34 V2F plus 0.13 divided by 3.02 equals 0. So I'm going to end up, when it all shakes out, I'm going to have V2F is going to equal negative 0.13 divided by 3.02 divided by 7.34. And that's going to be a very, very, very small number. So it's going to be almost zero. So what I found is, in this situation, my one cart basically comes to a halt. So I'm going to call it basically 0 meters per second. So I just totally made up these numbers off the top of my head. I didn't really try to cook them at all. What we're going to find is, in this situation, this cart, when it collides with this cart, is going to basically just come to a standstill. Okay? Now, what we're going to do... Okay, so then what we have to do is we have to come back and we have to find the equation that we wanted. The equation we wanted is back to this one here. And we have V1F is equal to negative 1.86 V2F minus 4.33 meters per second. And so we're going to plug 0 in for this, and we're going to get, that's pretty easy, V1F is equal to negative 4.33 meters per second. Okay, so what we're going to find after the collision it's going to be rolling that way just a tiny, tiny little bit. And this one here, my 1.38 kilogram, it's going to be moving that way at 4.33 meters per second. Okay, so that's about as complicated as it gets, and we'll just move on to another topic in the next video.